Database management system.
Yes,
Sir, in fourth semester.
last semester.
Yes, sir.
Oh, okay. So that's good. Fourth semester, and probably ma'am taught it, right? RPS ma'am.
Yeah, ma'am. Yes, sir.
Okay, all right. So I'm going to start with very basic stuff like, today I'm going to talk about basically the uh, database system structure. Okay, the database system structure has two major components. What are they? And what are the different? There are also sub-components within those components. Basically, what do they do? What is their role? I will briefly explain, and then I'll go into database system architecture, just 2 tier and 3 tier, and then also I will talk about the ANSYS Spark 3 tier architecture. Basically, those are three levels, the 3 level ANSYS Spark architecture. That's all I have a plan to cover. Okay, so let's start. What are the two major systems of database system structure? By the way, Ritika, please name the group as distributed DBMS. Okay,
Okay, sir.
and underscore HD sir. Bus.
Okay, sir.
Distributed DBMS. That's the name of the class, and my uh, abbreviation is HD sir. That's it. Okay,
Okay,
underscore
sir.
HD sir. All right. Um, what are the two major components? Can someone tell me? Two major components. Database, if you look at database, what does it do really? I mean, why the database came into picture? There was file, and before database we kept our data in the files. Okay, and I'm not going to get into like why files are less efficient than DBMS system. I mean, you all know it. I don't want to waste time on that. Okay, uh, but just think from that angle, from file system. Okay, why we came for database, and that will actually help you to answer my question. Any idea, anybody? If your answer is wrong, don't hesitate. Okay, I'll give you the answer. Somebody wants to say something? All right. uh, See, the storage was there already. Okay, so the storage function of file system had already been there, but it was not so elaborate, it was not so efficient. So in DBMS system structure, it's broadly divided into two areas: storage manager component, and then there is query processor. Okay, the query thing wasn't there in file system. Okay, so that's a very efficient one. As you know, probably, like if you want to know something uh, in old file system, if you want to get some information, you have to always write a program, okay, to manipulate the data files, the program. And here you just simply write 2, 3, 4, 5 lines of queries, which you have written, I'm sure, SQL queries, and that will fetch the pertinent information for you. So these are the two major components: storage manager and query processor. Now, the storage manager is really important. Can someone tell me why storage manager is so important? Hello, can someone tell me why storage manager is important?
To handle the data.
Huh?
To handle the data.
Well, file system also handle the data.
To keep more data.
Not really. I mean, getting closer.
Efficiently storing the data.
Efficiently,
storing the data.
you can say efficiently handling the data maybe. Okay. The storage manager is important because database typically, need a large amount of storage space. Okay. Like, gigabytes, terabytes. Now, corporate database range in size from hundreds of gigabytes to terabytes of data. And a gig is approximately 1,000 meg. Okay, and so and terabyte is, again, 1,000 gig. That is 1 million megabytes. So that's 1 trillion bytes. Now, the main memory of computers cannot store this much information, right? The information or data is stored on disk. Now, data are moved between disk storage and main memory whenever you need it, as and when needed. Now, the movement of data to and from disk is slow relative to the speed of central processing unit. Okay, it is imperative that the database system structure uh, the data so as to minimize the need to move, data between disk and main memory. Okay. And query processor is also important because it helps the database system to simplify and facilitate access to data. The query processor allows database users to obtain good performance while being able to work at view level and not be burdened with understanding the physical level details, which we are going to discuss a little more in detail when we'll be look at, the three level ANSYS Spark architecture. So you don't have to worry about what's there in the physical level down there. Okay, so implementation of the system, it helps. It is the job of the database system to translate updates and queries written in a non-procedural language, that is SQL, at the logical level into an efficient sequence of operations at the physical level. Now, storage manager provides interface between the low-level data stored in the database and the application programs and queries. Okay, it has been created. Okay, thank you. Uh, the storage manager is the component of a database system that provides the interface between the low-level data stored in the database and the application programs and queries submitted to the system. The storage manager is responsible for the interaction with the file manager. Okay. Uh, the raw data are stored on the disk using the file system provided by the operating system. Storage manager basically translates various DML statements into low-level file commands. So storage manager is responsible basically for storing, retrieving, and updating data in the database. So what are the major storage manager components? Authorization and integrity manager. Authorization and integrity manager. Let me show you a picture that will help rather. Let me share my screen. Oh. All right. Oops. Here it is. Can you see the picture? Hello.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. You look at on the top of the picture. Okay. There are users on the top level. There are users. Okay. Like naive users means test agents, web users. They are not. They are actually huge. They make the biggest chunk of users basically. Somebody still want to get in. Abhilash. Hello, Abhilash. Abhilash. Acharya,
Hello. Hello, sir.
I'm talking to you. Please do not be late from next class.
Okay, sir. Sorry, sir.
You won't get in.
Okay, sir.
Okay? Because it's very difficult if somebody interrupts like this. Keep on. So
Sorry, sir.
naive users
I
are
will keep it.
actually the big bulk of users. Then comes, application programmers, those who basically write application programs that interact with the database. Sophisticated users, DBMS analysts, and then of course DB has to be there. The database administrator is the last one. Okay. Now, uh, in the query processor, the storage manager, if you look at it, the one down there, let me change this if I can. Yeah, that's our storage manager. Okay, there is authorization and integrity manager. So if you look at the name, you can really easily tell that what does it do. Basically, it tests for the satisfaction of integrity constants. Those integrity constants, and checks authority of users to access the data. Check, checks for the authority of the user to access the data. That's the job of the authorization and integrity manager. Transaction manager. Okay, which ensures basically the database remains in a consistent or correct state despite system failures. Okay,
Excuse me, sir.
all yes.
Sir, we can't hear your sound properly and we can't show this image. So, can you share it in group?
Sure, I will share that in the group. No problem with that. I will send it in the WhatsApp. Okay,
Yes, sir.
that I can do that. But can you hear my voice properly now?
Yes, sir.
Hello.
When you
Okay.
share the screen, we can't hear you.
What is the exact problem? Can you repeat?
So, when you
So your
share
voice
the
was
screen,
breaking, sir.
Voice was breaking, and what else?
And the image is like not properly rendered.
images are
So
just blurred.
Blurred? How about
Yes,
right
sir.
now? How about right now?
Right now is
now
okay.
Yeah.
when you're moving the
Okay.
image, so it is getting blurred.
Okay. Now it's okay, right? Okay. So you can see authorization and integrity manager. You can see the transaction manager. Transaction manager basically ensures that the database remains in a consistent or correct state. Okay, basically there should be no system failure and concurrent transaction execution. That is very, very important in today's database. Concurrent transaction execution uh, proceed without any conflict. Okay, then there is file manager, okay, which manages the allocations of space on disk storage. Okay, see, files are still there. Okay, so file manager has to be there, which manages the allocation of space on disk storage for different files and the data structures that is used to represent information stored on disk. Okay, and then there is buffer manager. That is the most important. Okay, storage manager, if you compare storage manager and query processor, okay, as I told, the storage manager plays a very important role for DBMS execution. And within storage manager, there are four components: authorization and integrity manager, transaction manager, file manager, and buffer manager. Now, buffer manager plays a very important role. As I already mentioned, this is the one which is responsible for fetching data from disk into the main memory, that is RAM, and deciding what data to cache in main memory. Okay, buffer manager is a critical part of the database system because it enables the database to handle data sizes that are much larger than the size of main memory. As I told that in the hard disk, the data that is there is in terabytes, and our RAMs are not in terabytes. Okay, so how to handle that, like what part of the database should be uploaded in the RAM and what needs to be swapped. The old data that is in the RAM, that needs to go back to the or removed, making enough space for the newly required data and all that. That is basically the job of buffer manager. Okay. uh, Now, storage manager implements several data structures as part of the physical system implementation. For example, data files. Okay, as there is file manager, there will be data files which store the database itself, and then there is data dictionary. Data dictionary. Any idea what is data dictionary? You should know after doing DBMS. What is data dictionary? Metadata. What is metadata? Data dictionary stores metadata. What is metadata?
The data about
Information.
data.
Huh?
Data about data, I think.
Yeah, data about data. Basically, data dictionary, uh, which is very much required actually. Um, Metadata stores metadata, and metadata is nothing but data about data. Okay, basically it talks about, it tells you like structure of the database, schema of the database, and then which component is what, which data is what is their nature, uh, type, and everything. All those thing in detail. Um, and then there is indices which can provide fast access to data system. Okay, like the index in a textbook. Okay, a database index provides pointers to different data items that hold a particular value. Okay, we could use an index to find the instructor record with a particular id, for all instructor records with a particular name. Hashing is an alternative to indexing that is also faster. So the that is also basically, these are the things: data files, data dictionary, and indices. Um, these are also part of the physical system implementation that storage manager basically handles. Then we go to the query manager. Okay, the query processor. Sorry, query processor. Query processor has components like DDL interpreter, DDL compiler, and query evaluation engine. Okay, DDL interpreter, DDL compiler, and query evaluation engine. Basically, these are the three things. These are very important components. The query processor, DDL interpreter, which basically interprets your DDL statements. What is DDL statement? Do you remember from SQL what is DDL statement?
It's a data definition language.
Can you give me an example of a DDL statement?
Create table, alter table.
Yeah, create table order. Thank you very much. Very good. DDL. Just to recap a little bit, making sure that, oh my God, DDL. You want everybody remembers what is DDL, and then DML is data manipulation. Okay, there is a DML compiler basically that translates DML statements in a query language, okay, into an evaluation plan that consisting of low-level instructions that the query evaluation engine understands. Okay, so basically, DML compiler's job is basically to um, translating DML statements, translating DML statements. Why this is translating DML statements basically in a query language into an evaluation plan consisting of a very low level instructions. Okay, that the query evaluation engine understands, just like any other like C compiler or Java um, or uh, Python. All these languages have compilers. What they do is basically they translate your high level code into low level machine instructions, which the machine understands. Simply the same thing here. And then a query normally actually that is very important part or efficient role of DML compiler. It doesn't only translate it, and actually query can usually be translated into any number of alternative evaluation plans. Have you done any query optimization in your DBMS class? Hello.
No, sir.
Yes.
No,
Yes.
sir.
Oh, so you know what is query optimization.
No,
And
sir.
Yes.
No, sir.
oh, no,
No,
sir.
sir. No, sir.
No, sir.
Ma'am said that you will teach us query optimization.
Query optimization. No, 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 no. That is not my part. Something is wrong. I'll talk to ma'am then. Okay. So a query can usually be translated, and DML compiler actually performs what is query optimization. That is nothing but it picks the uh, lowest cost evaluation plan, basically. Okay, the lowest cost evaluation plan from all the alternatives. Okay, and query evaluation engine is the last one which executes low level instructions generated by the DML compiler. Okay, the query evaluation engine which actually uh, uh, executes the low level instructions generated after the DML compiler translates, and that's your the job of basically query evaluation engine. And if anyone has any question, I already talked about this different users. Okay, but they are external to the DBMS uh, system structure. Okay, so mainly these are the two things. One is storage manager, the other one is query processor. Okay, uh, then we are going to get into two-tier and three-tier DBMS system architecture. Okay, uh, just a second, share the right picture. Oh, okay, here it is. Uh, can you see the picture? Hello,
Yes,
hello.
sir.
Yes, sir.
Okay,
Yes, sir.
Okay.
all right. The database system, this architecture of database, uh, you can predominantly divide it into two groups. One is two-tier architecture, the other one is three-tier architecture. Okay. Uh, Basically, architecture of a database system actually greatly influenced by the underlying computer system on which the database system runs. Database system can be centralized or client server, where one server machine executes work on behalf of multiple client machines. I mean, you guys have a bad luck. Normally, when we do the offline labs in college, uh, there the system in the lab runs in this fashion, the client server fashion, because there is a Oracle server and students work on client computers. Okay, and the server is across the hallway to another room, maybe connected to all these um, client computers in the LAN. So that is a good example of two-tier architecture. And three-tier architecture, can someone tell me a good example of a three-tier architecture? You have used it, all of you. All of you have used it. A
Sir,
three-tier architecture. Huh?
browser.
Browser. You are close. Elaborate it a little more. You are close. A browser is not a three-tier architecture. Browser is an application which lets you surf the net, basically.
Then like search engine like Google.
Sir,
Yes.
searching
Any
something, sir. Searching something.
any websites?
Searching something or buying something from Amazon. How about
Yes,
that?
sir. Yes,
We
sir.
all
Yes.
Snapdeal. Snapdeal, buying something, basically web applications which has database. That's all.
Yes, sir.
Web page has to be there, and in the back end there is a database server, and you are doing it from your handheld Android phone, or maybe your laptop or desktop. That is your, I'm sorry, that is your, basically, that is your, why the light is so little? Let me try this. Oops. Yeah, little better. Okay. So these are the basically three-tier systems where you are using whatever the device you are having in your proximity. That might be an Android phone, that might be a laptop or computer. That is the client machine, and then there is the web server. Okay, uh, uh, the basically application server, basically uh, that holds, basically the machine that holds the web page of Amazon or Snapdeal or something. Um, and then mm, uh, and in the back end there will be a database system, which is the third layer. So basically the first layer is you, whatever system you are using, that is the first layer. Second layer is the web server, and the third layer is in the back end, the database system that is having the database server, basically. Okay, these are the three layers. And the client machine basically acts merely as a front end, basically. It does not contain any direct database calls. Okay, instead the client end communicates basically with an app server, usually through a forms interface. Basically app server means with a web application, uh, application server, and then in turn communicates with a database system. Let's say you are searching for a particular merchandise in Amazon. Okay, in that case, uh, application server of Amazon or web server of Amazon will communicate with their database system to access that particular data. And business logic of the application, which says what actions to carry out under what condition, okay, is embedded in the app server, that is the web server. Okay, instead of being distributed across multiple clients. So this is three-tier applications. Okay, and then there is two-tier application, as is client and server. Basically students in our college, when they do the database lab, as I gave you an example, you are using uh, in the computer that you are sitting, that's the client machine. It invokes the database system, basically, and its functionality at the server machine, that is in the Oracle server, sitting in maybe another room somewhere, or could be in the same room, doesn't have to be uh, you know in some other room, but that's a altogether separate machine, and that is considered as another tier. And uh, basically you invoke the database system functionality in the server machine through your different query language statements. Okay, so application program interface standards like ODBC and JDBC. ODBC is nothing but open database connectivity, and JDBC is I think that works with Java, I guess. uh, Java database connectivity, I guess, are used for interaction between the client and server. Those are APIs, basically application programming interface. That you know API works, like that is the interface between the client and the server. uh, that is the application or software part. Now I'm asking you an example. Let's say you are buying a ticket uh, from Howrah station. Maybe uh, yeah, you are buying whatever ticket you are buying. I mean, like, let's say you are going to Lucknow and you are buying a ticket for Lucknow, from Howrah to Lucknow. What kind of database system structure that DBMS system is using? Two-tier or three-tier?
So 3 tier thing.
Why?
Or so that
Because data is already
the ticket
the
counter is the like client, I think client server kind of.
Yeah, that the
And
the, the counter
database
person, the
server is accessing that data.
okay, you said three-tier. So what I'm asking you, please elaborate on that. Like, which one is the tier 1, which one is the tier 2, and which one is the tier 3?
No, sir, I think it's a 2 tier, sir, because
Ah.
yeah, sir, he's
Okay,
directly
now,
accessing it from the database.
yeah,
Yes, sir.
it just explain to your friends and to me also, like, why you think it's two-tier, not
Because
three-tier.
there is no client application platform. He's directly the main, like he's directly using the application and accessing a database.
Yeah, there is a computer. Like, if you go buy a ticket, the ticket clerk is using a computer. That is the client machine, basically. Okay,
Yes,
and
sir.
all those clerks are using the client machine,
And
that is connected by wide area network. Maybe there is a centralized server. Okay,
yes, sir.
if the server is somewhere in the Howrah station, it will be LAN. Otherwise it might be somewhere, I don't know, really, railway people know. It could be totally centralized, and uh, I don't know, uh, whatever the case may be. In that case, centralized or not, uh, it could be local server as well. I believe it's a two-tier architecture. Okay, client
Yes, sir.
server architecture. Okay, and all the web applications are basically three-tier architecture. Okay, so you pretty much understand two-tier and three-tier architecture. Okay, um, I what time do you have another class? From 1:20?
Yes, sir.
Hello. 1:20. It's already 19. uh, I don't want to get into the ANSYS Spark three-tier architecture and other things, like database instance. What is those um, uh, what is the uh, just let's discuss a little bit, like, what is the most important purpose of three-tier architecture? ANSYS Spark three-tier architecture. What For what reason
Sir, client application.
No. Somebody else, please.
Manage greater
Somebody
number
else.
of users.
What? What?
Manage great number of users.
No.
Sir, client
The
does not use database directly.
the yeah, kind of getting closer. Kind of getting closer. You remember anything about
Sir,
data
limited access. I
independence?
think, sir, limited
Data
access.
independence, physical data independence, logical data independence.
Yes, sir. Yes, sir.
Yes, the major goal is basically, and another reason is like uh, from all over the
Sir,
world. Yeah, go ahead, go ahead.
sir, I think
Somebody
it's like
wants to say.
banking. When we access banking details, we can access only ours. And when the some banker access it, he can access any data like that, sir.
That's a
Basically,
view level thing.
limited
That's the
access.
last. That's the topmost level, view level. Yes,
Yes, sir.
that is one part of this. And another thing is data abstraction. Basically, abstraction, data abstraction. You have done object oriented programming in Java. Okay, so what is data hiding, abstraction, and stuff. Basically, hiding the complications or complexities of a software system from you. Okay, you don't have to. You are a user. You don't have to worry about how this is physically stored, the data and all that stuff. Okay, you just do your thing. Okay, you are the user. So there are basically three levels: physical level, logical level, and view level. View level is the one where basically we act, the users. Okay, uh, and the main reason actually this was proposed, or uh, this was rather administered by ANSI. ANSI, do you know what is ANSI? ANSI, what stands for ANSI? ANSI. Come on, you should know all these. These are ABCD IT graduates. Don't know
So it is a
NC.
standard.
Yeah, it's a standard organization in America, American National Standard Institute. Basically, they are the regulatory body, and they actually decide what should be the standard, basically, what standard they should follow. All these people are like coming up with different database systems, different companies. So they said you must follow this ANSI Spark, and I really forgot Spark. I have to look at it. SPARC. Can someone Does someone know what is Spark? Just Google it. SPARC. It will tell you. I forgot. It's been so. Basically, major purpose of a database system is to provide users with an abstract view of the data. Okay, so the system hides basically certain details of how the data are stored and maintained. Not only how the data is stored, what data, and how they interact and all that stuff. Okay, so uh, so in the physical level, basically how the data are actually stored. In the logical level, what data are stored. And
Sir.
then view level. Hello.
Yes, sir. Sir,
Yeah.
it's Sun Pharma Advanced Research Company.
SPARC.
Yes, sir.
What?
Sun Pharma
No.
Advanced
No, no, no,
Network.
no, 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 something else with database.
Sir,
So
Sir,
sir,
scalable
scalable
processor
processor.
architecture.
What?
Scalable processor.
Scalable processor architecture.
No, 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 no,
Sir,
no.
the
a scheme for
scheme.
promotion of academic research and collaboration.
I don't think that one
American
either.
National Standard Institute Standard Planning and Requirement
If you
Committee.
write NC and then dash Spark, it will give you the whole thing. I know NC, American National Standard Institute, and Spark is another organization, I think.
Standard Planning and Research Committee.
Absolutely, absolutely. Standard Planning and Research
Committee.
Committee. Standard Planning and Research Committee. I think, I'm not sure, maybe this is the, uh, you know, European counterpart of ANSI or something could be. I will talk about it the next day. I will do a little research in the net. I will tell you a little more about ANSI and Spark, and then I will start discussing this ANSI Spark 3-tier architecture. What is it, and how it actually helps us to achieve the physical data independence and logical data independence. Okay. uh, and we'll finish all these things and in the next class next week, and move on to whatever the next topic is. I guess probably I have to look at it, relational algebra maybe. Okay. All right. Okay. Then let's end it right here. Okay. Ritika, hello. Ritika,
Yes, sir.
yeah, can you do me a favor?
Yes.
You just take a snapshot of all the students, all your friends present in today's class, and mail it. Sorry, not mail. Forward it by WhatsApp
Okay, sir.
to my number
Okay, sir.
for the attendance. Just take those screenshots or something, whichever way you prefer. ठीक है?
Okay, sir.
Okay. All right. Bye now.
हो गया अटेंडेंस।
1 सेकेंड लीव मत करो कोई, मैं स्क्रीनशॉट्स ले रही हूँ।
हाँ क्या
जो लीव कर दिया उसका क्या?
आ गया तुमको कोई बोला हाँ क्या करने के लिए आ गया चप चप
हो गया, लीव कर जा।
हाँ क्या